Hello students, welcome to Saurav's classes. In this video, I'll be explaining more of the multivariate statistical methods. So now, I will be talking about logistic regression. Logistic regression. So logistic regression is a statistical technique for analyzing a data set in which there are two or more independent variables that determine an outcome which shall be a binary variable. Outcome will be a binary variable which is usually coded as 1 for one factor and 0 for all other factors. 0 for all other factors. Now, let's move on to multivariate normal distribution. Multivariate normal distribution. It's a very used statistical tool, and you can say the most used distribution you can call this. The reason is that the assumption of normality is common to parametric inferential statistics. Such an assumption is based on multivariate central limit theorem. Based on multivariate central limit theorem. This holds good if the number of discrete data or ranks may be 30 or more. This holds good if the number of discrete data is 30 or more. The notation of this PDF will be f of x is equals to 1 by 2 pi to the power p by 2 sigma to the power half exponential of minus half multiplied by x minus mu complement sigma to the power 1 x minus mu. Now, in this case, we can say that expectation of x is equals to mu and expectation of x minus mu multiplied by x minus mu complement is equals to capital sigma. Also, suppose x minus mu dashed is equals multiplied by capital sigma to the power minus 1 multiplied by x minus mu is equals to c square. This particular part is known as Mahalanobis squared distance between x and mu. This is known as Mahalanobis squared distance between x and mu. Let me add a page. The expression for c squared describes the surface of an ellipsoid centered at mu. Surface of an ellipsoid centered at mu. Now, let's move on to a very important question, that is, what are the properties associated with a random vector following a multivariate normal distribution? Properties of x, which is a random vector following multivariate normal distribution. Okay, I'll answer this point wise, so this will be very distinct and clear to you. Let's see. So point wise we can write that as one linear combination of components of x follow multivariate normal distribution. Point number 2 is all subsets of components of x follow multivariate normal distribution. Number 3 is if all the covariance between components is 0, then it is implied that the components are independent. Components are independent. Number 4 is the conditional distribution. The conditional distribution of the components of x are also, let me add a page, multivariate normal. The next point is the equidensity contours of the components of non-singular multivariate normal distribution are ellipsoid, centered at the mean. Point number 6 is if the components of x are independent with equal variance, then contours are spheres. Contours are spheres. Let me add a page now. There is only one point left, and that is if the covariance sigma is not of full rank, then multivariate normal distribution is degenerate and does not have a density. Well, thank you for watching the video. Hope this helped you solving your queries and brushing up your concepts on multivariate analysis. For more videos, you can keep checking our channel and stay tuned. Thank you.